Hello. In this video we are going to look at some problems involving current in series and parallel circuits. Now if we start with series circuits, these are relatively easy. So at a very kind of introductory level, which is these initial videos what they're about, you'll be given the current in the circuit somewhere. So let's say you have a cell and you have a bulb. I'm going to put an ammeter over here, an ammeter over here, and I'm going to put an ammeter over here. Now when you draw circuits, you should use a ruler to connect everything up. Just because that takes a bit of time for the video, I'm not going to do that, but I'm going to be very, very neat. There shouldn't be a line here, sorry, but I can't undo because it's for real. So this point here, this circuit, very simple. Now if I told you the current here was 0.1 amps, you know what the current in the other ammeter is, because in a series circuit current is the same everywhere. Okay, so that's our number one rule with series circuits, current is the same everywhere. And it doesn't matter how big the circuit gets. So if I take another circuit here, and I'm going to put one cell even, but I'm going to put two bulbs. And in this circuit, I'm going to represent the current slightly differently than I did before. So in this circuit, I'm going to look at the current at this point. I'm using the arrow to represent the current going from plus to minus, but at that point, I'm going to look here, I'm going to look here, I'm going to look here, I'm going to look here. Now hopefully you're looking at this and you're thinking, right, what is the value of the current? But actually you might be asked something more simple than that. You might be asked to think about and talk about what the relative currents are. And all of the currents here are the same. So it doesn't matter what value they take, they are all the same. Now I'm going to give you a little trick here. You've got one cell and one bulb here. Remember, the ammeters, they're just watchers, they're meters, they just look at what's going on, they don't interfere. So you've got your cell and you've got your bulb. Here you've got two bulbs. Now the bulbs add something we call resistance to the circuit, and with two bulbs you've got twice that. So if you've got two bulbs operating, they're sort of in their normal way, you've got twice the resistance. So in this circuit the current will halve, and that is because it's twice as difficult to get through. So we had 0.1 here, we will have 0.05 here, and we'll have it 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 here, because current is the same everywhere in a series circuit. In different circuits it will change, but within the circuit it's all the same. And remember, this twice the number of bulbs means half the resistance. Now here's another trick. If I keep my one cell, but I put three bulbs, 1, 2, 3. I'm going to look at the current at this point, and this point. But really, I need to look at it at one point because it's the same everywhere. At this point, people sometimes say, right, 0.05, you've added a bulb, we halve 0.05. But that's wrong, because at this point, we doubled the number of bulbs, which caused the current to halve. But here, we haven't doubled the number of bulbs. What we've done is, ignoring this one, from this point, we've increased the number of bulbs by 3. So at this point, we increased by number 2, so by 2 bulbs, which means we divide the current by 2. From here to here, we increase the number of bulbs by 3. so we divide the current by 3. So this will be 0.333, lots of 3's amps, it's a third, 0.333 amps, 0.333 amps. Okay, remember current is the same everywhere. If I increase the number of cells, so in a battery you're never sure how many cells there are, but in this case with the cells specified you do know. So if I took this circuit and I say K, I'm going to put 2 cells for 1 bulb. I'm going to put an ammeter there. What do we think is going to happen to the current here? Oh, I've left 1 cell. I'm going to draw a second cell. There we go. That's the circuit I meant to draw. 2 cells, 1 bulb. 1 cell, 1 bulb. So twice the number of cells, twice the energy in the circuit, 0.2 amps. And if I put 3 cells in, with 1 bulb, and I can put the ammeter on this side in this one. Sorry, this one's not quite as neat. But put that on that side. Remember, you haven't doubled this number of bulbs, you've tripled this number of, sorry, not bulbs, cells, which means 0.3 amps. So hopefully you'll start to see the relationship here. Now at this point, I think it'd be useful to look at parallel circuits, but I'm going to do that in a separate video.